Okay, um, so I wanted to talk a bit about some of the large language model tools, techniques, hints, and tips. So I've worked with a number of scientists, and uh, some of those scientists can get themselves in quite a muddle with their data. It's very easy to lose data. It's very easy to draw a nice figure or something, and then lose the code to draw that figure. So I think a key part of doing data science really is being really organized. Now I know that you're all excellent computer scientists, so apologies if some of this sounds basic, but I thought it might be useful to go through some of this stuff. And also, if you disagree with me, do stop me, or if you have any questions, please stop me along the way. So I think that doing data science is often about going around and round in circles. So, what we're doing here is we're running experiments, we are data wrangling, we're thinking, reading, doing all of these different activities that all constitutes doing scientific research. But often it seems to be the case that what happens is that you do some reading, you do some thinking, you experiment a bit, you make some mistakes, you fail, and you kind of go back around this loop. So with all of this kind of looping going on, you need to be able to go back in time and understand what you did a week or so ago, or maybe 2 weeks ago, because you might want some data, or you might want a figure or some analysis that you did a while ago, and now you need to be able to find it. So I think that the more organized and the more automated you are, the faster you can iterate, so that the better you can do this kind of data science. So what I want to kind of explore is, how can you be organized, and what kinds of tools allow you to do that kind of automation. So one of the things I really like, and there are I've got lots of slides with suggestions. You don't have to do any of these, but they might be of interest. So I don't know whether you're aware of something called the cookie cutter data science. But cookie cutter data science defines a kind of clear file system layout and conventions that make it kind of easy to find stuff. Now I take that and use that, but I also change it a bit. But you can see here it's pretty basic stuff. You've got a data directory where you put your data. You've got literature where you put your literature survey and your papers that you're reading. You might have a manuscript directory where you're storing the writing that you're doing. You might have a reports directory and a figures directory where you store the figures that you're making, the graphical illustrations of the data, and you might put your source code into source, and you might have some binaries, some a bin data, some tools that you've built that you want to use. And then under data, you kind of, you need to kind of split that up according to the kind of data that you're using, and we'll talk about that shortly. So I think it's important to think also about the data lifecycle. So often you receive some data from somebody else. So that might be a list of questions, it might be some experimental data or whatever. And so the convention from the cookie cutter data science people is that goes into the external directory. So that's stuff that you've received from outside. And the rule is that you never change that. You always need to be able to go back to the original data. So if somebody sends you a spreadsheet, you never start editing that spreadsheet. You would store that spreadsheet exactly as it is, because you might want to go back to the original data. They might be experimental data. You don't want to overwrite it, and you don't want to get confused. You've also got data that you're obtaining from your own experiments. So you might run some LLM evaluation experiments, and the convention is that goes into the raw directory. And again, you never change the data that you've captured. You always need to be able to go back in time and sort of look at exactly what went on where. So we use this word immutable. You never change those things. And then, but often it's the case that you need to sort of tidy that data. You need to convert it and combine it into what is often called tidy data, and that's the stuff that you're actually going to do the analysis on. And so you might be combining different data sets, and that the convention is that goes into interim. And then if you have any published data that you want to publish with your paper, that goes into processed. Now, I don't mind whether you use this particular convention or not, but the big takeaways is if you've captured some data, never change that data, and the other one is don't throw data away unless you really have to. Keep all the data, keep everything, and it turns out that when you're doing LLM evaluation, particularly, most of the data that you're working with is textual, and so the good news is that textual data compresses really well with tools like zip or XZ. So you don't need a lot of disk space to keep all this stuff. Even if you're doing really large experiments, you can often zip that stuff up and probably even store your data in something like GitHub along with the code. So there's no need to throw data away. That doesn't tend to be really big. Now, obviously, if you're working on with image data or video data or doing something really big, then you might have problems with disk space and you may have to throw data away. But I think the general rule is never throw data away. I think it's really useful to use Git and GitHub for version control. Now everybody uses this for code and and these days, and that's good. But it actually can be really useful for version controlling data as well. If your data is not too big, I mean there are some hard limits in GitHub. I think it's the largest individual file size can be 100 megabytes. But as I say, if you're zipping up data, you can often keep the data as well in GitHub, and there's no problem with that as well. So I'm sure you know all about GitHub, but the main reason for me for that is it avoids this kind of versioning problem of where you have some file and you have your version 1, your version 2, draft 2, and you can very quickly get confused. You get to this point where you've got your final version, and then something still changes and it still needs revising. You want to avoid this problem and just have one directory and look at all of the versions going back of that thing. So GitHub is great because it provides this kind of time machine. If something goes wrong, you can always go back to an earlier state and get the data back again. It's really good because it gives you an offline backup. If your laptop fails, you've always got a copy back in GitHub. And believe me, laptops do fail and disk drives do fail. Many years ago, I worked in a data center, and it was a large data center here in the UK. And disks would literally, there were many hundreds of thousands and thousands of disks there, but disks would literally fail every few days. When you see disks failing, you get really nervous about backup. So please make sure you've got copies of data. The other nice thing about GitHub is it allows for kind of collaboration. You can share your code and data with somebody else that you're working with, and you're not going to get out of step, and you're not going to get into trouble there. And you can go back and say what's changed and when. So I'm sure you're probably familiar with Git and GitHub, but if you're not, there's a really good introductory video on YouTube by a colleague of mine at the Turing Institute, and it's his name is Dr. James Geddes, and he does a PhD sort of tutorial on version control with Git. So I highly recommend that if that's something that you're not totally familiar with at the moment. So the other thing to think about is the data formats that you're going to use. So you tend to receive data in many formats. It might be CSV, it might be spreadsheets, all kinds of stuff, text files, JSON, Arrow, all sorts of weird formats. And a lot of what you're going to be doing is joining data together, taking some data from one place, combining it with something else, changing it into questions. So you might have some data, I don't know, about some directions or something, and you want to turn that into a list of questions. Well, you're going to have to transform that data in some way, and we call that data wrangling. And so the idea is that tidy data kind of assembles this data into something that makes it convenient for you to work with. So with tidy data, you don't worry about duplication. What you'd worry about is getting the data into a format that makes it really easy for you to do your job. So if you've kept the original data, it doesn't matter how you transform it into that new data, you're never going to mess anything up. You've got the data in a state that is ready for you to use. You want to think carefully about how you're going to identify the data. So having identifiers, numbering questions sounds really simple, but people don't do that kind of thing. I was working with some people recently that we ran some LLM evaluation on a bunch of questions, and then they couldn't easily cross-reference the questions with the answers because they didn't have any kind of numbering scheme. If they'd have just numbered their questions and numbered their answers using the same numbering scheme, it would have been really easy to have done a join and to find the correct answers for the questions. So I know that sounds simple, but I see people making these kind of mistakes. And I was just going to say that, one of the really advantages of using text here is that it's both machine readable, or it can be machine readable and human readable. So thinking about data formats, the way you're going to store the data is a really important part of the game. So one very popular format, particularly for LLM evaluation, is something called JSON-L. So this is the JSON lines format. And in JSON lines format, each line in your text file is a piece of JSON. So here's an extract with an ID of 62. There's a question and an answer, and you would have lots and lots of these all in a text file. Now, the nice thing about this is that you can just look at this file, read it yourself as a human being, but also you can really easily load this into Python and start working with it, or work with it in a variety of other languages as well. So it can easily be edited, and if this gets really big, if you've got maybe 10,000 questions, you can still have this in a text file. It can be compressed, but you're making life convenient for you. If you store this in some binary format, then it can become very difficult to work with these data. So thinking about having something that's human readable and machine readable is a really good idea. You also need to think about, what's the use case for the data. So with JSON-L, that's really about having something that the computer has written out that you can read. But if you're going to have to type a lot of data in, you also want textual formats that are easier for you to work with and easy to type in, that the computer can still read. And there are other formats like YAML, which stands for yet another markup language, or there's one called TOML, which is Tom's obvious markup language. But you can see they're really easy. If you were to bring up a notepad and just start typing some data in, this is the kind of format that you might use here if you were storing a list of LLM models. Just by using this syntax here, you instantly make this machine readable, and this can be read into a table in a Python program or something. So some people prefer YAML, that's the one on the left, and some people prefer TOML, which is the one on the right. You can see that there's quite a lot of similarity there, slight differences, but those are both useful formats to think about using. If you're going to use textual formats, so Demetrius has got a question.
Yes, I was wondering why are we using JSON for the data, and we use something different, YAML or TOML for the model and the specifications of the model. What's the difference between
Yes, I think it's a good question. I think JSON-L is useful when the computer has generated it. I mean, you can edit it yourself, but it's quite hard to edit in a notepad. It's more work. So I think kind of JSON-L is where the computer has done it first, and you're just reading it. And I think then these other formats, where are we? YAML and TOML are useful when you're typing the data in, and then you're expecting the computer to read it. So it's about kind of making life easy for yourself. It's easier, I think, to type this YAML stuff in than it is to type all of these brackets in. So and it's easy to convert one from another. In just 2 or 3 lines of code, you can go from typing something in YAML and turning it into JSON-L if you want. So it doesn't matter. But these are not hard and fast rules. They're things for you to think about, and for you to do whatever's convenient for you. But I'm sure you agree, typing that in is a lot easier than all of these kind of curly brackets and stuff. And the other thing about YAML is it's a lot less strict. If you have extra spaces in there or stuff, it really doesn't matter too much. So I really recommend that you think about how you're going to edit text files. You need a really good editor. I think most people these days use Visual Studio Code. I don't know what you guys are using. In the old days, because I'm an old guy, I tend to use Emacs, and lots of people use Vim or VI as well. Those are more difficult to get using, but they're probably more powerful. But certainly you need a good editor. So it's better not to do all this stuff using something like Notepad. So I was working with somebody just a couple of months ago, and they were editing JSON-L files using Notepad, and it was a really bad idea because they couldn't see where the brackets were, and the JSON-L file that I got back didn't work because they'd missed some brackets. If you use something like Visual Studio Code, you get all this nice syntax highlighting. It's all color coded. You've got all lots of nice key presses for doing stuff. So I would definitely recommend selecting an editor and using it. Probably Visual Studio Code if you've not already using one of the other things. But yeah, get good at using a good editor because you're going to be using it probably quite a bit. So I wanted to talk about automation. So the problem that you'll face a lot with editing text files is that manual data editing, it can be very error prone. So often it's better to write some Python script to transform data than it is to go and edit that. So if somebody gives you a file with 10 questions in it and you need to change those questions very slightly, it's probably easy just to go in and edit those questions in an editor. But if it's 100 questions or 1,000 questions or 10,000 questions, that's going to take you far too long to do. So it's really a good idea to think about automation, to write scripts to do the job. And what you tend to find is that, if you have to make some changes to a file and you have to do that once, the chances are you'll need to do that again at some later point. So if you have some tool or way of doing that, that's reproducible and will save you time later. So if you're not familiar with regular expressions, some regular expressions are kind of ways of searching and replacing text. Thoroughly recommended. They're a bit difficult to get started with, but highly powerful, and they're supported in things like Visual Studio Code. So you can go into Visual Studio Code, you can say search and replace using a regular expression, and this allows you to do some very sophisticated searching and replacing of particular text strings. I think when you're writing scripts, it's really good idea to avoid hard coding paths and file names. So often I work with people that give me a script, and that script will only work on their machine because it's got their username in it, or it's got a path to their where they store their data that's different from everybody else. But think about kind of including those things as arguments to a function, or at least putting those things into variables so that they can easily be changed. And if you have a good script, then that script becomes a kind of reproducible record of what you did. So when you come back, you've done some experiments, and you go back and look at those experiments maybe 3 months later, and you're scratching your head trying to remember what you did. If there's a script there written in Python or something, then that can be the thing that helps you to remember exactly what you did, because that Python script will show you the steps that you took. If you did those things manually, you'll have forgotten them. But if you've done those things in an automated fashion, you'll still have that script there to see what was going on. And if you get really more advanced at this stuff, I thoroughly recommend something called make and just. And you can have these kind of make files and just files, which are like recipes. So they're the thing that link all this stuff together. You kind of, with a make file or a just file, you can say, in order to go from my base data to my questions, I run this script. In order to go from the questions to running this on an LLM, I run this script, and then I have another script perhaps to evaluate my answers. And you can combine those all and orchestrate those all using make files or just files. So they're a bit more advanced. You don't have to use those, but they're some things that you might want to think about at some future point. So I really like this Unix philosophy, and the Unix philosophy is all about writing programs that do one thing well, writing small programs that are composable, that work together really well, and writing programs that predominantly handle text, because text, as we've seen, is something that you can look at, and also something that the computer can work with as well. It's machine readable and human readable. So you want to write scripts that are easy for you. Writing a script is not just about writing something for the computer to execute. It's about writing it for you to remember how it works and to be able to understand it. And so generally, it's a good idea to prefer things which are simple and clear and composable, things that can work together, and to really avoid complexity. And I've worked with some people where they had these huge scripts, thousands and thousands of lines, and it was really, really difficult to figure out what was going on. And when I tried to run the script, it wouldn't work, and so on. If they'd have split that up into smaller pieces and stored some of the intermediate results, then I could have narrowed down the bit that wasn't working much more quickly. So I commend this kind of Unix philosophy to you. but you don't have to be working on Linux. These days, sorry, that's the wrong slide. These days you can use this kind of Unix approach on Windows. There's something called the Windows subsystem for Linux that allows you to have a command prompt that's Linux essentially running on Windows. If you have a Mac, that's got a terminal environment, and if you are on Linux, that's got a terminal environment as well. And it's all more or less the same kind of thing, but it's worth, I think, investing time looking at these kind of Unix tools, and we'll see some of that in some of the later slides as we go on. So here's some examples of working with the JSON lines format from the shell. So here I can say WC, which is, if I say WC minus L, that says that's a command that counts lines. So I can count the number of questions that I'm using by doing WC minus L questions. If I want the first 5 questions, I can do head minus N5. There's a command called JQ, which is JSON query, and that allows me to pretty print out these questions in a nice way. I can combine things using these pipeline operators, so I can take the output from all the IDs from my answers file, I can sort them, get the unique ones, and then I can count those. So I can count the number of unique IDs. So by having these things, I can really quickly look at the data and play around with it without having to write too much code. But if I do have to write code, that's the way you can load these JSON-L files into Python. You just read them in with one line into a regular data frame. So there are lots of good tools for doing this kind of Linux stuff out there, and different ways of doing this. Some of the ones that I like is JQ. There's one called ripgrep, which is really good for searching stuff. So if you've got lots of questions and you want to find the question that had a particular word in it, or an answer that had a particular word in it, ripgrep is useful. UV is a useful package manager tool for Python, so you can make sure that you know exactly which dependencies your Python program, which libraries it's using, and then XZ is really good for compression. So I think it's interesting to think about scientific programming, which is what we're doing. It's very different from writing other kinds of programs, because often what we want to do is write a script that runs correctly once. So we're writing once and running once, whereas lots of people who write software, write once and then run it many times. Generally, we're just writing code to run once. So what we want to do is to make sure it's correct. And the way we can do that is to think about sanity checking. So it's useful to have in our program things that count the number of rows. Have we got the number of rows in our table that is the same number as the number of questions that we were thinking about? Or is there some variable? Is it, if there's a probability, is it between 0 and 1? It's useful to put sanity checking code in things that it's often called assertion-oriented program. So you put an assert statement in, at this point in the program, I'm expecting the variable X to be between 1 and 5, or I'm expecting the number of rows to be 1000 or something. Having those double checks is a good way of making sure you don't kind of shoot yourself in the foot and get into trouble. It can be a really good idea to write out intermediate results. So rather than just having a big long script that does loads and loads of things, takes the input, transform it lots of times, and then the final output, dump out some of the intermediate results and just have a look at the intermediate data to make sure it looks like what you're expecting it to. So that's another useful, another reason for using textual data if you can, because you can easily look at the intermediate steps. So exploratory data analysis is all about looking at those intermediate steps. So generally, the idea is to prefer short, reusable scripts over one big kind of run it script. It's better to have lots of small things loosely connected that can be reused and composed than to have one massive script. And I wanted to say something about comments as well. So often when scientists are taught to write programs, they're taught put lots and lots of comments in. And that's generally quite a good practice. However, you tend to find that as code changes over time, you can get to this situation where the code and the comments actually disagree. So you can have somebody has updated a line of code, they haven't changed the comment accordingly, then it can become very confusing. And there's a guy called Ron Jeffries who said, if the code and the comments disagree, then both are probably wrong. So there's this interesting thing in programming, which is we're all told to write lots of comments, But actually, quite often it's about writing clearly named functions and variables, and they can be more informative than actually putting comments in. And so if the code is really clear, sometimes you don't actually need the comment. And I used to work in the computer software industry before I started doing research. I only got my PhD a few years ago, but before that, I ran a software company and worked a lot with Microsoft. And what we tend to find is that as developers gain experience, their use of comments evolves. So what you tend to find is that new programmers don't write enough comments, and then mid-level programmers tend to write too many comments, and then really experienced engineers only write comments where it adds real value. They've learned that having too many comments is a bad thing, having not enough comments is a bad thing, but having comments that really help the reader is a useful thing. When we're doing these LLM experiments, we need to think carefully about experimental design. Obviously, the more questions you have, the longer the evaluation is going to take, and the more expensive it's going to be. And the more models you use, the more time and expense is. So you need enough questions and you need enough repeats to show some kind of statistical significance. You probably want to show error bars in your work. But you don't want too much stuff that it's going to take you forever and cost you too much money to run. So there's a real balance there, and it can be hard to figure that out. But talk to me. I can help you with some of that when the time comes, if you wish. And you also need to think about how you're going to score your answers when you ask an LLM a question and it's going to answer that question. How strict are you going to be? Is it going to have to get the answer completely correct to score a mark, or might you allow for it to have some error? Maybe you'll give it half marks if it's doing okay. So you need to think carefully about that, and you need to think carefully about what's the nature of the experiment you're running. And often it's useful to do some small scale experiments first just to kind of assess feasibility. So often if I'm going to do a big LLM experimental run, I'll just copy and paste the questions into one of the questions into ChatGPT and play around with its wording a bit first. So I'm not spending too much money. I'm just playing around with it. And then when I understand, when I'm clear about the wording and clear that the LLM is going to give me the kinds of results that I'm looking for, that's when I scale up to do the big experiments with maybe 1,000 questions and 3 repeats or something. One thing you need to think about when you're designing your experiments is this, what we call the reviewer 2 problem. So if you've ever written a paper and submitted it to a journal or a conference, you'll be familiar with this idea of reviewer 2. So you often, when you write a paper, you submit it to a conference, you get 2 or 3, usually 3 reviews back. And quite often the first review might be reasonably good. They think, yeah, we like your paper. But they tend to always have one miserable reviewer who doesn't like your paper, who's trying to catch you out, who asks all sorts of awkward questions. And you have this reviewer too, and you just go, oh no, why is he asking? So it's a good idea to think about what a reviewer might ask you before, as you're designing your experiment. And common things that reviewers ask when we're submitting papers on LLM evaluation is they say, why didn't you try such and such a model? So they want to see that you're using some of the latest models. They usually want to see that you're using some small models and some large models. So you need a real, kind of representative mix. That you often get criticized if you don't put error bars on your outputs. You often get criticized if you only use commercial models and not open weights models, and likewise if you only use open models, and then they say, well, what about the big commercial models? They often ask about sensitivity to prompt engineering. Why did you ask the question that way? Did you try using a different way of wording the question? And the other one is they always say, wouldn't your results improved if you did such and such? And there's loads of papers out there on prompt engineering, chain of thought, all kinds of things you can do there. So that can be a problem as well if they come back. So it's worth thinking about up front, what these kind of criticisms might be and trying to head them off as you design your experiment. And the other big one that I get, which really frustrates me, is that I do an experiment on a new benchmark that we've created, and then the reviewer comes back and say, yeah, well, why didn't you try such and such a benchmark? And the problem always is there's hundreds of benchmarks out there, so which ones do you choose? And so you have to think carefully about what is it about your benchmark, your questions, that's going to give you a definitive answer. So anyway, this can be difficult, but if you can think about likely objections early on, then you can do something to kind of mitigate those. It's worth thinking a bit about the statistics you're going to capture when you do your evaluation. You really do need to think about error bars, because these models are stochastic in nature. So you ask ChatGPT some question today and you get this answer. Is it going to give you the same answer tomorrow? If you do 10 runs, if you ask the question 10 times, it's unlikely you're going to get exactly the same answer 10 times. So you need to know kind of how often it's right. It might be right once, but would it be right 9 out of 10 times or 7 out of 10 times, that kind of thing. And so one way to look at that is to use confidence intervals, and there's lots of literature on confidence intervals, but my preference actually is to use prediction intervals. And I've written a paper about this. The paper itself is now a bit out of date, but the bit about confidence intervals and prediction intervals I think is useful. But the essence of this is that a confidence interval is trying to predict the mean or a parameter from the underlying distribution, whereas a prediction interval is trying to give you an idea of the confidence that if you repeated this experiment, would you get the same answer that you or an answer that's similar to the one that you've already provided in the paper. So don't worry too much about this. Confidence intervals are fine, but prediction intervals I think are a bit more useful. And you also, there are other statistical things to think about, like, are you going to use the mean or the median and so on. So the mean is usually used, the average of some scores is usually used, but sometimes the median might be more appropriate, particularly if you've got outlying results. So again, we may talk about that if we're working together on these projects going forward. A big part of LLM evaluation is visualizing data. So I just wanted to show a few graphs that you might like to use. So this is the kind of thing that you often see in a paper. I've coloured the bars here, but often you test several models. Now I don't expect you're probably going to be testing as many models as this. In this paper we were required to test a lot of models, but you might test 5 or 10 models, for instance, and you want to know which model is best. And I call these bake-off diagrams, but they're just bar charts. But you'll notice that the bar charts have got the score actually written on them, which makes it easy to read up. You don't need a separate table. There's a red dotted line, which is the guess rate. So that allows you to see that all of these models are doing better than guessing. And you can color you can use color on the bars if you want to distinguish different kinds of model, for instance. So that's a common way of presenting that sort of data. Often we want to test some effect, so here in this particular experiment, I was interested in whether when I asked my questions, if I used she is or he is, did I get a difference in results? And so this is a useful way of pulling that apart and putting these error bars on. So here on the left-hand diagram, you can see that very clearly she is performs a lot worse than we are in the question. So these kinds of diagrams are a way of pulling apart these different effects and showing statistically significant differences. And another useful piece of analysis is using tokens as a proxy for reasoning effort. So when you run an LLM, often you get a response back from the LLM, but you also get information about the number of tokens it actually used. Now, that number of tokens can be quite interesting. So in the experiment we did here, we were looking at directions north, south, east, and west, and we found that the intercardinal directions tended to use more tokens than the cardinal directions. So we think that is because these intercardinal directions are somehow kind of more difficult, need more reasoning effort than the core cardinal directions. So looking at that is an interesting way of sometimes looking at data in different kinds of answers. It may not be direction, it may be something else, but counting the number of tokens and comparing that can be useful. We quite often see these kind of heat map type diagrams where you want to compare something. So here I'm comparing a large number of models down the left-hand side with about 9 different experiments. And I'm wanting to show that the PA experiment on the right is a lot easier for the LLMs than the RCC22 experiment on the left. So this gives me a very quick indication that there's more yellow here. The models are doing better. than on the left, where it's more blue. So it's kind of brighter is models that are doing better than others. So consider these kinds of pictures as ways of showing, of presenting your data. What's working and what's not working. Confusion matrices are also really useful. If you ask a question that has an actual answer and a predicted answer, then you can use these confusion matrices. Demetrius, you've got a hand up.
Yes, excuse me for
No, go ahead.
interrupting.
This is great.
On the previous slide, I noticed that different calculi offer different results. So when we experiment with the models, should we use the last one, which seems to be the most efficient one, or should we experiment with different calculi?
It depends on. So it's very much dependent on what you're trying to say. In this particular case, the paper required us to test all of these different calculi and to say which ones were easier than others. So we were wanting to say that, for instance, RCC22 was a lot harder than the point algebra PA on the right. So I don't think there's any hard and fast rules here. I think it's a case of what you're trying to say in your paper. What is the experiment that you're trying to do? What are you trying to say? And here I was just really trying to point out that this can be a useful visualization, using color as a way of representing questions which the LLMs find easier or harder can be a useful way. So yeah, we can talk about your specific experiment and what might be a good way of representing that data, but it depends what you're trying to do, I think. Is that okay? Yeah, so confusion matrices are useful. So in this case, we have questions where the answer is north, south, east, or west, but the LLM is predicting north, south, east, or west, and we can see that this strong line here, this particular LLM, which is the GPT OSS 120B, is doing a lot better with north, south, east, and west. The numbers are higher there than with the intercardinal directions, northeast, southwest, etc. And you can see where it's confusing answers. So if we look at the northeast column, for instance, we can see that when it's predicting northeast, 77% of the time it really is northeast, but it's often confusing it with northwest, or it's confusing southeast. So it gives you an idea of where the LLMs are deriving their confusion from. So that's a useful kind of view. So let's just do kind of LLM evaluation in a nutshell. These are the typical steps that you're going to be going through if you're going to be doing LLM evaluation. That's not to say that we're open to ideas. I think there are new things that can be done, but this is the kind of way that things tend to happen. So first off, you tend to create some list of questions and answers, and that's often kind of impractical to do manually. So usually you're generating those questions from some kind of program. Then you tend to prompt one or more LLMs and record the answers. So you might you might choose GPT-5. You might choose some smaller language models like Llama 3 or something, and you'll ask those questions and record the answers. The LLMs themselves are stochastic in nature, so you're going to have some experimental repeats. They're going to give different answers on different runs. So you want to know generally, what's the mean answer that they give. You're going to be evaluating those answers, and you need to think about how you're going to do that. So when you look at the answers, are you going to go through those manually, marking them like you might mark somebody's homework, or are you going to write a program to try to automatically evaluate the answers? Or are you going to use another LLM, another large language model, as a judge? Are you going to give the question and the answer to another LLM and say, is that correct? Now, that last thing sounds like a good idea, but it's a bit dodgy because the judge could be wrong as well. But these are things to think about. You're going to do some kind of bake-off, probably ranking the LLM's performance, but each model, which is the best model, which is the worst model. You're probably going to be doing some kind of error analysis, looking for some insight into how the LLMs work. What are the systematic errors that it's making? Where is it confusing things? What does that tell us about reasoning in LLMs? You're probably going to be looking at reasoning traces for large reasoning models. So in a reasoning model, you get the answer, but you also get the reasoning trace. How did it come to that answer? Demetrius?
Yes, sorry again.
No, don't apologize.
What if there was a neurosymbolic LLM that used the neural part to generate to answer the questions, and the symbolic part to actually see if they are correct or not. So in this case, we wouldn't need to do it neither manually nor use another LLM as a judge, because that neurosymbolic LLM would do both things, and we would be certain that there are no errors here.
You're quite right. Yeah, neurosymbolic AI is a big field. It's really exciting, and using external solvers is becoming a big part of the game. So yeah, it's a very good point. I agree entirely. Thank you. Yeah, so you're probably going to be looking at token analysis, and you might be looking at mechanistic interpretability of your results as well. But that's generally the case. But we're not really, but understanding which LLMs is the best is not really all that interesting, actually. What's really interesting is where do they make mistakes, and what kind of mistakes are they making, and are those mistakes similar to the mistakes that humans make? That tends to be much more interesting analysis, I think. So I just wanted to say something briefly. I've got a few more slides left to go, and then we'll turn it over to questions because the time's getting on, I can see. But I wanted to say something about writing. So there's somebody called Leslie Lamport who I got to meet a few years ago, and he said that if you're thinking and not writing, you only think you're thinking. And he also said that writing is nature's way of telling you how sloppy your thinking is. So basically, what he's saying is that you need to be writing. You need to be, if you need to be writing things down to help with your thinking. So I would certainly encourage you to start writing, even at this early stage as you're thinking about the projects you're doing. Start writing things down. What are your ideas? What are the questions you're interested in? What kinds of methods might you use? What data might you use? And it's easy to have these thoughts in your mind and forget them later, but those kind of thoughts can be structured carefully by just starting to write things down. And I mean just either typing things into a notepad or into Word, or writing things in a notebook. I think as you do these experiments, you will come up with more and more ideas and more lists of things that you want to do. So you need to have some kind of way of organizing that, and that might just be some text file that you keep your to-do list in. But things like Google Keep is a really useful thing. Not everybody knows about that, but it's a free piece of software that's useful for maintaining to-do lists, and you can kind of you can very quickly capture an idea. Wouldn't it be nice if I did such and such an analysis? And then you can review those lists and schedule the work on different times. And it can be also useful to keep a journal of the work that you're doing as well. What experiments are you running? Why are you running them? What results did you get? What did you find out? Why did you abandon that experiment? You might have done an experiment, thought, well, this isn't very good, but write down why that's not very good, because you might want to come back to that later and see what you did. And the other useful thing about keeping a journal is sometimes it can be a bit depressing doing research, because sometimes it seems like you're not getting very far. But actually, it can be useful to look back over the last week and say, actually, I worked quite hard. Although I got some negative results, I had some good progress. So I would certainly encourage you to write down what it is that you're doing. And I think when it comes to writing the paper, start thinking about the target journal and the conference and your readers. Read some of the papers from that journal, because all journals have their own kind of style. And start structuring your paper and using the same kind of wording and structure that those papers use. It can be really useful to think about topic sentences. So when you write a paragraph, it's really useful, if you can, to have the first sentence say everything that paragraph really means, and then have the rest of the paragraph just providing additional information. If you can write these one-line sentences and sort of their bullet points, then those become the bullet points for a presentation later, but they also tend to structure the paper really nicely as well. And I wanted to just say that writing papers is much more about editing than writing. So it's really important that you just get on and write. Most people are kind of worried about writing and their writing's not very good or whatever. But the best thing you can do is just to write down. And there's a number of people who call it your shitty first draft. What they mean is the first thing you write is usually really bad, but you've got to write something bad to then make it better. So don't sit there thinking I'm not very good at writing. This writing is not very good. Just get it written down, however badly it is. Once you've got something that you've written down, even if it's really bad, that's the thing that you can then mold into a really good paper. But all good papers start out being really bad papers. There are some people who can just sit down and write a really good paper. And Tony, who I work with, who you met the other day, he's one of those people. But most people have to start by writing a really bad paper and then making it iteratively better until it becomes a really good paper. And the other thing to say is that some people find pen and paper easier than a computer keyboard. I do sometimes. So sometimes I'll intentionally walk away from the computer and just to start writing. Manolis.
What did you say about Tony?
Tony's very good at writing. He seems to have this skill of being able to write papers very quickly. I suspect you are very good at writing papers quickly as well.
I'm better at correcting them.
Well, exactly. So it takes me a long time to write a paper. I have to write it really badly first and then improve it. But I have seen Tony write a paper in more or less a day or two. If he's and I can't do that. It takes me weeks. And so I just wanted to encourage people to not be embarrassed and to just start writing. Really, I think it's really important to write. Yeah,
I agree.
So I think it's a good idea to use the LaTeX markup. I have worked on some papers with some people who just do them in Microsoft Word, and that's okay. But they tend to get in a muddle very quickly because what's the latest version? What are you going to do about your equations? The tables and things in Word just don't tend to look very nice. Things can be made to look really nice in LaTeX. There's a system called Overleaf, which is really good. I'm presuming you've got access to that. If not, then we can probably provide access to that. And that's a useful web-based system for writing LaTeX, and it enables you to collaborate. If there are 2 or 3 people writing, you can all be writing on the same document at the same time, which is really helpful. And LLMs are actually really good at helping you to do LaTeX markup. So I don't remember all of the LaTeX commands, but I know that if I know what I want to do, and I can go to a ChatGPT and say, I've got this paragraph here, and I want to turn this into a table, or I want to make this bold or italic or whatever it needs to be, or I want to write a macro for this thing. And ChatGPT is really good at helping with that. So don't be afraid of starting to use LaTeX if you've not used it before. And the other thing to say is don't manually edit tables if you can avoid it. It's much better to write a script to create the LaTeX table than it is to then cut and paste that into the paper rather than typing in numbers. As we said earlier, when you're typing numbers, that's when you make mistakes. So it's better to have a script that generates the table, and then you put that directly in the LaTeX, and you know that your table is going to be absolutely correct because it came from the very code that ran the experiments. You do need to be careful about using LLMs with your own work. And one of the things we need to check, and Manolis, you might be able to advise on this, is whether your university has any rules or guidelines about AI assistants. So you do need to be careful about that, particularly if you're writing a thesis about whether the university allows you to use LLMs in that writing. Most of them do now, but you need to be very careful. So the thing I would say is that it's important to use an AI as an assistant. And never to trust its answers. You're the one with the brain. Use it. So by all means, use LLMs. LLMs are really useful for helping with literature reviews. So there's a system out there called Undermined, which claims to do your literature review for you. It doesn't. It does half a job and gives you something that you can then work with. So there's no harm in using it, but you've got to do your literature review. LLMs are really good at helping you refine your writing, but you need to be the one who's doing the writing. Don't let the LLM write the paper for you because it will be terrible. You've got to you use the LLM to help you reformulate a sentence or reword something by all means, but make sure you're in charge of the writing. Similarly with coding, it's, you know, these LLMs are great at coding, because you can say, I've got this data here in a data frame with this structure and these columns, and I want to show a confusion matrix, and it will write you the code for that confusion matrix. But you've still got to check that code, you've still got to check that data and make sure that visualization is absolutely correct. Yeah, and the other thing to say is that don't, you know, if you're formulating a benchmark set of questions and you're using an LLM to do that, then those questions can leak into the training data set for the next version of the chatbot. So be very careful about what you're sharing with the chatbot. Anything that you type into a chatbot, you know, could end up being the training data in the future, and that could mess up your future results as well. Okay, I'm going to stop in a minute, but there are two or three tools that I have that you're very welcome to make use of. One is called Golem, and this is a useful tool for running LLM experiments. If you've formulated your questions in the JSON-L format, as we talked about before, then this Golem software, you can literally say, Golem, say which language model you want to run. So I want to run on Azure, I want to run GPT-3.5 Turbo, whatever settings you want to run, however many repeats you want, and then send in the questions that you want, and you can have a long list of maybe 1,000 questions, and it will just run all those questions for you and keep all of the answers. The nice thing is it keeps all of the answers, all of the interactions, so everything's reproducible. I have this thing called JSON-T, which is a templating system. So it turns out that, you know, lots of times what we want to do is translate one JSON kind of line into something a bit different. So suppose we had a colors.jsonl file listing color names and hex values, and we wanted to turn that into HTML. You can do that by using this kind of template here. So I won't go into details here, but this is really useful for formulating questions and for taking data sets and turning them into questions, and pulling out the answers and so on. And this works really well with that JQ tool that I talked about earlier. Then there's another tool which is I've only just come out called Telos, which automates HTTP calls. Now, if you're using advanced features of large language models that are not supported by the Golem software, particularly if you're going to do something with multimodal work, then this is the tool for you. This allows you to take any JSON-L file, translate it into something that you can then run against any API. So that might be I use it with video generation, for instance. So I think a lot of the experiments that we're probably going to do will work really well with Golem, and that's the simpler one to use. But if you have advanced requirements, this is the tool for you. And with that, I'm going to stop sharing and stop talking, because I've spoken probably already for too long, and just see whether you have any questions. I hope that was useful and not too much of a brain dump.
Yes, it was useful. Thank you very much, Rob. I have a tiny question. You were showing something like GPT OSS, something like that?
Yes.
Which one is that one?
So that's a model that OpenAI have open sourced the weights on.
Oh, I see. Okay.
So it's a version of GPT, but it's only there's the two versions. There's a 20 billion parameter and 120 billion parameter, and it's an OpenAI model, but it's not their best stuff. It's not their commercial grade stuff, but it's still useful for some things, and we use it quite a lot for evaluation because it's relatively low cost but relatively good.
Okay.
If you're interested in models, then there's a website. There's a provider called OpenRouter. I'll put that in the chat. Yes. And if you search for OpenRouter models, they've got most of the models there, and you can find their capabilities and compare and contrast. But there are hundreds of models out there now, and so you can't test everything.
May I ask something else too?
Of course.
How are we going to create the JSON files with all the questions we would need, which would be more than 1,000, perhaps?
Well, we need to think about that. But suppose it depends on exactly the problem that you're going to tackle. But you could write a Python program that generated all the combinations of parts of the question that you wanted, and then generate the question, and then save that out to JSON-L, for instance. That's so we do lots of that. So for instance, we might have a template question, something like, you're walking north along the east shore of a lake, and you could have that in Python, and then substitute the directions for north, south, east, and west. And so suddenly you have a template with one direction in it, let's say, and then you can change that direction to one of 8 directions, and suddenly you have 8 questions automatically just by having a for loop in your Python code.
So after we make this file, we would need a way to test it with a variety of models.
That's right.
And that's where Golem comes. So Golem, we will use Golem for to avoid writing scripts that would call many APIs. Golem
That's
does
right.
it for us. Okay.
That's right. So you can do. So I need to be clear that I'm not mandating that you use these things. There are options for you. If you want to write your own code, if you want to use your own APIs, that's up to you. But these things are there to be used if they're of help to you. So I need to tread this careful line, because these are the methods that I've used, but that doesn't mean to say they're the best methods. They're just the methods I've been working in doing this stuff for about the last 2 years. So this is what I've come to do. But if you have better ideas, then you must say, and if you find better tools, then you must use them as well. So entirely up to you. But these are there and available for your use if you wish.
I have noticed that some APIs do not use the same parameters or the same way to use some parameters, maybe. Some agree on that, some disagree on that. Does Golem take that into consideration, or it is more for the general way that OpenAI uses?
Yeah, so that's a really good question. So the way that Golem works is it tends to use an OpenAI chat completion type approach as input, and then it will translate that as far as it can to those different to those other LLMs. So you can use Gemini, for instance. So where it supports an OpenAI style of interaction, the chat completion interface, it will use that. If it can't use that, it will try to do some translation for those other LLMs. Now, in most cases, it gets that right, but there are some edge cases where that's just too difficult, and where it becomes too difficult, particularly where it's complex and you're doing lots of multimodal stuff, images, videos, and so on. That's where the Talos tool comes in. So I got to the point where Golem was working most of the time, and it was dealing with kind of 80% of the work that I need to do. But then 20% of the time, there were these really obscure cases and these obscure models that I needed to use, and that's when I used the Talos tool. That's why I built the Talos tool, to have ultimate flexibility. But for most cases, Golem, 80% of the time, Golem will do the right thing. And try it and see, and if you find bugs or want changes, then you're welcome to contribute pull requests to these tools as well. There's I did some work with somebody at Liverpool University, and he made some extensions to Golem. So he actually improved the code and contributed that back, and so that's now there for everybody to use as well. So actually, these are not difficult programs. They're fairly simple programs. The JSON-T program that I talked about I think is only about 80 lines of code. It's not a big program, and so if you want to look at those programs and see how they work and improve them, then by all means do so. Good. Any other questions?
Sorry again about something.
Yeah, keep going.
The last question. Orestes, do you remember when you showed me your code about evaluating different models, there was a problem with some models that we couldn't pass some parameters at the same way.
Yeah, it was about the provider and the library that each company used.
Yes, and I noticed that Golem uses the command line to pass parameters.
Yeah.
So it should take into consideration these limitations.
That's right. So
Yeah, that's right.
It
Okay,
does.
okay.
I can't guarantee that it will work for every parameter in every instance, but the thing to do is to try Golem, and Golem always dumps out every request and response, so you can always check exactly what was sent and what was received back. We always keep absolutely everything. As I said in my presentation, I'm a real stickler for keep all of the data, and I keep every LLM conversation for every experiment that I've ever done, so I can always go back and say exactly what did I send and exactly what did I get back. So I can, and that's useful because sometimes you need to check these parameters. Did I really set temperature to 0, or did I set it to something else? You know, what was the exact response? Did I get an error message? Were there any warnings? All of that's there. So I like keeping everything. And also, you know, if you get a reasoning, if you get the reasoning summary, that's all there as well. So you can evaluate the answers to the questions, and then at a later date go back and say, well, actually, what was the reasoning that their model used to get to that answer?
Yes. Okay, thank you very much.
So by all means, have a play with those things, and come back to me with any questions. I'm very happy to drill in on specific things. So if you started using Golem, you wanted to use that, we could do a separate quick session on that. But today I wanted to just kind of give you an overview of the things that you have available, and go from there really.
Yeah.
Can we download the slides so we can review them while we were working?
Of course, yeah, I'll share the slides with you, and I think this is being recorded. So also, if you want to play this back, I think there might be a transcript as well with that. But any questions, you've got my email address, so do come back to me with questions. Always happy to have a separate chat. I mean, I'm really excited about the work that you're taking on. I think these are important projects to do. I'm really excited to see what you'll come up with, because I hope that you'll have some different ideas and take these projects in your own directions. I don't want these to be about us imposing, the project has got to be done exactly like this. I hope you're going to take these ideas, have your own ideas, and run with them and turn these into your own projects. But we're absolutely here to help and to collaborate as well.
So maybe the next step, Rob, would be to have individual sessions with the teams, because in some cases we have one person, in some cases more than one, and see what the first reaction is to the project and make some planning. So what I will do is I will create what was the name of that tool that I used, because Doodle gives you so little choices these days. It's amazing. So I'll use that French tool, and I will send you a link to vote. Don't look at the dates, okay? Look only at the days, day and time. And vote what you can, because we will do this as a bi-weekly meeting to keep track of the work, and that's it. Yeah, I'll send the link in a little while.
Great.
Okay.
Well, if there are no further questions, I'll wish you all a very happy Christmas holiday break, and look forward to working with you in the new year.
And to you, Robert, all the best. Enjoy the holidays. Best wishes to everybody, and we'll see you soon.
Absolutely. Look forward to it. Thanks, everybody.
All the best. Thanks a lot, Rob.
Thank you very much.
Bye.
Bye. Happy holidays. Bye-bye.
Bye-bye.